November, week 3, math, 2nd grade, lesson 1, word problems. Ooh, you guys like that one?
Mm-hmm.
Okay. A sultan in Persia has 3 different colors of gemstones. If there were 62 of each color, how many gemstones does he have altogether? Do we know all the stuff? No. Make a box. Now put a question mark. Is the stuff the same? Colors and gemstones? No. So we can't put the stuff down here in the same place, can we? Because it's not the same. So we're going to make the bubbles, right? When the stuff is not the same, we've got to make the bubbles. Because they go in different places. And how many different colors? 3 different colors, good. And how many of each color does he have? 62. And what's the only sign that can fit without popping?
Times.
Good, Alder. It slides between the bubbles, right? These are what we know, and it slides between the stuff we know. So it's a time. So when we write it, we're going to write 62 for the multiplicand and 3 for the multiplier. Okay.
Yes, this is.
Can you all see that okay? 62 times 3. We're also going to put the problem number next to it. It's number 2. You can put that in a little circle. Great.
Wait, I'm not.
While we're getting some people caught up, this is the multiplicand. What's that?
Multiplier.
Nice. That's our multiplier. And this is called the product. JD, I'm in a lesson. And what's my finger on?
Multiplier.
Good. Multiplicand. What's my finger on? Multiplier. What's my finger on?
Remainder.
Product. Remainder is when we do takeaways. Great job, Leif, because the remainder does go down at the bottom like that. But that's for takeaways, so this is called the product. We always get products from times because you're making groups. We talked about that, like if you make M&Ms, right? You gotta put the same amount in each bag. Even if you're making thousands of bags of M&Ms a day, each bag has to have
The exact
the
same
exact
amount.
same amount. And
In the exact
so
same
3 is
size.
going to make exactly 62 3 times, right? It's not going to make different stuff. It's going to make the same stuff. Luckily, we don't have to do it thousands of times. Bead frames up.
3.
Beads in the bank. We're going to do units first. So go to your multiplier. 3 groups of 2. Go to your green units. 1, 2, once. 1, 2, twice. 1, 2, 3 times. Did you all use your fingers to keep count?
Mm-hmm.
Now it's a little harder. How many tens? 6. Keep frame on the ground, Leif. How many times? 3. Go to your blue tens. 1, 2, 3, 4, 5, 6. Good job. And again. 1, 2, 3, 4, 4, 4, 4, 4, 4, 4, 4. Exchange for 100. 5, 6. Twice. 1, 2, 3, 4, 5, 6. 3 times. And we're done. Let's write it down. We're going to get a product now. How many units?
6.
6. How many tens? 8 tens. And how many hundreds?
1.
He has 186 gemstones altogether. Do you think this guy's pretty rich? Oh yeah.
And he has one different. He only has one. He's 4 different colors. He also has that orange stuff.
I'm thinking they're counting that as this sort of golden color. Yeah, you're right. That one's kind of.
Probably he has one of those.
Yes.
Well, let's choose. You're looking at the answers.
Nope. I'm just. Ooh, I want to do this honeybee one.
No.
I like the next one on top.
Oh, we're doing the honeybee. A honeybee visits 206 flowers, looking for nectar, but another little bee has already been to some of them. So, 54 of the flowers don't have any nectar. How many flowers do have nectar?
Times.
Well, listen carefully. A honeybee visits 206 flowers. And some of them have nectar and some don't. Do we know all the stuff? Don't guess, think about it. Do we?
No.
Oh.
Yes.
I'm going to read the whole problem again and I want you guys to think. Because you guys are just guessing. A honeybee visits 206 flowers. But a little honeybee has been there before, and 54 of those flowers don't have nectar, but the rest do. How many flowers do have nectar?
Times.
So, did it tell us all the stuff?
Yes.
Yes, that's better. You guys were listening. Yes, it told us how many flowers he visited. Good job. So we're going to put that in the box. So it's 206. Is the stuff the same? Flowers and flowers. Yeah, it is, right? Some have nectar and some don't, but they're all flowers. So this time we can make the parts here in the same spot. We are not doing the bubbles. Do we know part of the stuff? Yes. How many flowers did the other little bee visit? 54. Good. 54. Leif? Do we know the other part? Did it tell us? So what kind of problem is this? What kind of problem is this? Good, Andrew. This is going to be a takeaway. Does it matter which number goes on top?
Yes.
Yeah, Alexis says it does. She's right. Can we take this big guy from that little guy?
Yes.
No, Alder. You know better. We have to put the big guy on top when it's a takeaway. Okay? So we're going to write 206. Take away 54 equals. If you guys would like to put the problem number in a little bubble or a little circle, it's problem number 35. That's super helpful for the teacher, right?
Why?
Because then if you were doing this problem by yourself and then brought it to me, I would be able to look up the answer really quickly. And then we don't have to stand in line for a long time. Okay, so we're going to do 206 take away 54. This is called the minuend. The lower number is the subtrahend, and then this is the remainder. Good. Leif, that's your word, right? Remainder. What's my finger on? Minuend. Good, Alexis. What's my finger on?
Subtrahend.
Subtrahend. What's my finger on?
Remainder.
Put your finger on your subtrahend. Good. It's the smaller number. Put your finger on the minuend. Good. Top number. Put your finger on the remainder. Yeah, good. Down in the lines. We don't know what it is. Okay. We're going to make the minuend. Right? Beads back in the bank. Units first. How many units? 6. 1, 2, 3, 4, 5, 6. Next we have some 10s, but we don't, so we're just going to move some air. Next we have a couple of hundreds. Go to your red hundreds. 1, 2. And now we're going to subtract units first. How many? 4. So back to the bank they go. 1, 2, 3, 4. All right, Leif said, uh-oh, it says to take away 5 10s, and we can't, so what are we going to do?
Go to the bottom.
Exchange one of your hundreds and get, how many 10s can you get for that?
Every single one.
All of them, right? 10 10s. That 100 is the same as 10 10s. Now can we take 5 away? 1, 2, 3, 4, 5. Does it say to take any hundreds away?
No.
No. Let's write down our remainder. 2 units. It's because you need to leave your bead pin on the ground. Okay, Leif? How many 10s?
5.
5 10s. How many hundreds?
1.
So he still had a lot of flowers left with Paul, and I think he's going to be just fine, huh? With nectar in the... What do they use the nectar for?
Honey.
Yeah.
But people take apart their honey.
We're going to do a couple more. Boris the birdie can crack.
No.
Boris the birdie can crack
Yes.
7 nuts a minute. How many nuts can he crack in half an hour? And then it actually has a little clue. It says 1 hour has 60 minutes, so a half hour would have 30 minutes. Good. So how many nuts can he crack in 30 minutes? All right. Do we know all the stuff? No. We don't know how many nuts he can crack in 30 minutes. Make a box and put a question mark. Well, we'll do that in a minute. Can you make a box and put a question mark? We don't know. How many? Oh, wait. Is the stuff the same? Nuts and minutes. No. So we got to make the bubbles, right? We cannot put the stuff in the same place if it's not the same. Okay, it says he can do 7 nuts in a minute, and he's going to go at it for 30 minutes. Gee, this little birdie's got a lot of energy, huh? So we're going to put 7 and 30. And Leif's right. It's A times. That's the only sign that won't pop those bubbles. That looks fine. Now we're going to go ahead and write it as an algorithm, and we're going to write 30 times 7. There's our algorithm. And we're going to write the problem number. This problem, ooh, it's 71. So that's one of the last problems. Okay. This is the multiplicand. What's that? Yes, multiplier. That's our worker. What's this? Starts with pr.
Product.
Good. Product. gonna make 0 units 7 times. That was fun, huh?
That was so hard.
Now we're going to do the 3 tens. How many times? 7. Ooh, that's going to be a little harder. Go to your tens. Are you guys ready? 1, 2, 3, once. Alder. Do 3 tens once, okay? Go back to your blue tens. 1, 2, 3, twice. 1, 2, 3, 3 times. One. Exchange. 2, 3, 4 times. 1, 2, 3, 5 times. 1, 2, 3, 6 times. Snackers, I'm in the middle of a lesson. 1, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, exchange. 3, 7 times. Use a scissors. It's too much plastic, please. Let's write it down. How many units? 0. How many tens?
3.
1. How many hundreds? 2. So that little birdie can crack 210 nuts in a half an hour. I bet that's more than you could do, huh?
210 nuts in a half an
Yeah.
hour. Crack.
Okay, we'll do one more. This one's about basketball. Alright. Ready? In a basketball game, one team scored 94 points. That's a very good score. But the other team won by 18 points. How many points did the winning team score? Do we know all the stuff?
Yes. No.
No.
Wait, Kimmy, I didn't see the last one of the last number.
Wait. Oh, it's. All set, buddy? Okay. So, guys, we don't know how much the winning team scored, do we? Put a question mark in the box. Is the stuff the same? Points and points. Yes. So can we put it in the same place? Yes. Good. So we're going to put a line and a line. And it said the first team scored 94, which is a very good score. Caden, make your lines kind of go all the way from one end of the box to the other. There shouldn't be a huge gap in the middle. Because these two things, Caden, should be the same as this, right? They are what we don't know. If you put these together, it's going to make that. So the first team made 94 points. We're going to put that on part of the stuff, right? But the other team got how many more?
18.
They got 18 points. And that's on top of the 94. So we're going to put that over here. And together, if we put that together, then we'll know how many the winning team got, right? So what kind of problem is this?
Plus.
It's a plus. Good job, Andrew. When we know both parts, they come together like a choo-choo train. And the choo-choo train's tracks look like that, don't they? The long pieces go like this, and the short pieces go like this. So 94 plus 18. Does it matter which number goes on top? No, it doesn't. Does it? Thanks, Kaden. Which one do you want to put on top? She wants the big guy on top. Okay, guys, ready? 94 for our top add end. And that means our bottom add end is going to be the 18. So you're making an algorithm. Put a plus sign. Remember, not a times, not a takeaway, a plus. Kaden, make yours look more like a plus. Lines at the bottom for our sum. And if you want to put the problem number, that's very nice. You can put 50 in a little tiny circle. Okay. We're going to make the top add end tens first or units first?
Units.
Units first. How many units does the top add end have?
4.
4. Good job, Andrew. Go to your green units. 1, 2, 3, 4. Walter, can you make it? 4 units. Okay. How many tens does the top add end have? 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we're going to make the bottom add end tens first.
Yes.
Is that correct?
Yes.
Do we ever do tens first?
Yes.
No.
Okay, units first. You go to your green units, and how many are we going to make? 8. 1, 2, 3, 4, 5, 6, 6, 6, 6, 6, 6, 6, 6, 6, 6, 6, 6, 6, 6, 6, 6. Exchange for that 10. Go back here. 7, 8. Can you leave the tens like that?
No.
No. Bye-bye. And get yourself 100. Okay, good. How many tens does it say we're going to add? 1. Go to your blue tens and add 1. There you go. So now we're going to write this down for the score of the better team. How many units did they score? 2. How many tens did they score? 1. How many hundreds? 1. So their total score was 112 points.
Did you know what the
Excuse me.
biggest
Wonderful lesson.